Hi friends, welcome to GMK Tutorials. In this video, we are going to see about the number system conversions. In previous class, we discussed the different types of number systems in the logic, digital logic design. Now, how we are going to converting from one number system to the another number system. If the number system having a base or that is converted to the another form of a number that is also equivalent of the base of the corresponding number system. So the conversion of number systems uh, is given below. Let us see what are the number system conversion. So one by one. So first one is nothing but decimal to any base number system. First one is nothing but decimal to decimal to any base number system. That means if you are converting from decimal number system, so any base means that it may be a binary, octal, hexadecimal number system. Any base number system. Second one is nothing but any base number system to decimal number system. So it's like a reverse operation. Any base number system to decimal number system. Third one is nothing but binary to any base number system. Binary to any base number system. And fourth one is nothing but octal number system to hexadecimal. Octal number system to hexadecimal. And fifth one is nothing but hexadecimal to octal number system. So these are the conversions of the number system. So first one is nothing but decimal to any base number system conversion. First one is nothing but decimal to any base number system conversion. Decimal to any base number system conversion. So if you want to converting from decimal number system to any number system to the any radix number system, you have to follow the two process. That is nothing but these are very important. First one is nothing but first point is nothing but first step is convert integer part of any base number system, and the second step is convert a fractional part of any base number system. First step is nothing but convert a integer part of any. First is nothing but convert integer part to any base number system. I will represent shortcut n system. Okay. At the same time, second step is nothing but a convert fractional part to any base number system. So for each and every part, it is also following different methodologies. First one is nothing but integer part conversion can be accomplished by successive division method. Okay, na? So first one is nothing but integer part. Integer conversion, just I will represent it very short. Integer conversion can be accomplished by successive division method. At the same time, second one is nothing but fractional part conversion. Fractional conversion can be by successive multiplication. Successive multiplication method. These are the two first primary things if you want to converting from decimal number system to the base number system, right? First of all, you have to convert from decimal to binary number system. So first one is nothing but decimal to binary number system. Decimal to binary number system. So in this one is nothing but first consisting of integer part as well as a fractional part. For each and everything separate part will be. I don't want to discuss this very thing. So step one is nothing but first one is nothing but for integer conversion. Just I can represent like this. So integer conversion first one is nothing but decimal integer is divided by 2. First one is nothing but decimal integer is divided by 2. Okay, leave the remainder. Next second step is nothing but step number 2. Divide the quotient. Divide the quotient with the quotient by 2 and leave the remainder. Here also same thing, right? Third one is nothing but repeat this step. Repeat step 2. Repeat the step 2 until the coefficient is less than the base 2. Repeat this step 2 until quotient is less than base of the number system. Here binary, so therefore it is less than 2. So that is a process, and collect the remainders from the bottom to top. You can get the equivalent binary number. And the last one is nothing but process is nothing but step number 4 is nothing but collect remainders from bottom to remainders from bottom to top to get equivalent number in binary or any number system. So that is a process, right? So coming to the examples point of view, I will consider a number that is nothing but 46. Convert this 46 number system into the binary format. I can represent like this, or else. So the question is convert 46, that is nothing but decimal number to binary. Suppose if you want to converting like this, so we can achieve with the help of a successive division operation, right? So let us see the scenario. 46, so it can be carried out with the help of a 2 because of converted base radix is equal to r. So ఏ నెంబర్ సిస్టమ్ ఇచ్చాడు మీకు, డెసిమల్ ఇచ్చాడు, బైనరీ అన్నాడు. సో ఏ నెంబర్ సిస్టమ్ అయితే మీరు కన్వర్ట్ చేస్తారో ఆ నెంబర్ సిస్టమ్ యొక్క బేస్ తో డివైడ్ ప్రాసెస్ చేయాలి. సో 2 2s are 4, 2 3s are, so remainder value is 0. Again coefficient is 23. So 23 is greater than base of the radix. Again you have to perform 2 11s are 22, remainder 1. Next 2 5s are 10, remainder 1. 2 2s are 4, remainder 1. So 2 1s are 2, so remainder 0. Now you can collect the remainders from bottom to top. You can get equivalent number system. What is the value scenario? You can represent 1 0 1 1 0. So 1 0 1 1 0. This is the equivalent binary numbers for decimal number of the 46. Right? So coming to the next one is nothing but just you will carry out the. I will give you one more example problem for you. You can do this one. Example is convert a decimal number of 115 to a binary number. Okay. Coming to the next one, fractional part conversion. So how to convert the fractional part? So the fractional part is almost similar for all the cases. Okay, just you have to see the scenario in the first step only. So the fractional part conversion can be done by the successive multiplication process and take only integer part and repeat the process until the necessary steps. Okay, so I will directly go through the problem. So convert 0.2 of 10 to get equivalent binary fractional number అంటున్నారు. Binary fractional number. So for that process is nothing but what is the scenario? Product, integer, fraction and separate. So in this process how we are going to process is nothing but ikkada it 0.2 can be multiplied with 2. A number system అయితే convert చేస్తారు, you will get 0.4. So what is the integer value here? This is nothing but integer, this is nothing but a fractional part. So integer value can be represented separately. So this integer value is 0. Again you have to take the corresponding fractional part. ఇక్కడ నుంచి fractional part తీసుకోవాలి. So 0.4 into again 2, that will gives us to 0. What is the integer value? 0 again. Again you have to carry it. 0.2 is equal to, you will get 1.6. So integer is 1. So this process is repeated if you need more number of accuracy. Suppose if you are taking 0.6 again, we will get 1.2. So again remind this. So this process is like this. So as well as if you want to represent the equivalent number in case of the fractional part, you have to take the corresponding integer part from the top to bottom approach. So they have to represent 0 0 1 1 is the equivalent number for 0. So binary number. So this is a decimal number. So steps enti, what are the steps manam chesindi first? So can you write these steps for this one? Step number 1, multiply fractional part by 2 and it will take integer part, right? Step number 2, what is the step number 2? How we are going to perform? Multiply the fractional part of the product in the step 2, step 1, producing the next partial product and separate the integer part. Okay, same. So again step 1, fractional part is multiply again and separate the integer part. Separate integer part. ఎప్పటివరకు until repeat the step 2 until the required data is obtained. Repeat the step 2 until required number. So here one important point is nothing but you have to clear, if you note if you need more accuracy, you will take more bits by integer part. So this is a process how we are going to performing the decimal to binary number system, right? So already example చూసేసాం, ఎలా కన్వర్ట్ చేయాలో కూడా మనం చూసేసాం. సో నెక్స్ట్ డెసిమల్ టు హెక్సాడెసిమల్ నెంబర్ సిస్టమ్స్ అంటే సేమ్ ప్రాసెస్. సో లెట్ ఇట్ బి సి డెసిమల్ టు హెక్సాడెసిమల్ నెంబర్ సిస్టమ్, డెసిమల్ టు హెక్సాడెసిమల్ కన్వర్షన్. So process will be same, right? Decimal to hexadecimal system conversion. So in this scenario, what shall we do here? So that is nothing but we are taking a 214 is the decimal number. So convert this decimal number to hexadecimal number system. ఇలా 16 మెన్షన్ చేస్తుంటే hexadecimal convert చేయాలి. So let it be see what is the scenario. 214, so that can be converted. ఏ number system కి అయితే convert చేసినామో you have to take the corresponding base of the number system. ఇక్కడ మనం hexadecimal కాబట్టి radix of the number system is equal 16. So what is the value? 16 3s, 16 13s. Then you will get around we will get the 208, right? So can you check it once? So 16 ones are 16, remaining 4 is the 5, 54 will be there, right? So 54 means that already you will take 48 will be there. So 48 and 54 around you will get 6 is the remainder. Therefore we will get 6. So this is a hexadecimal number. The final value is nothing but 136 is the hexadecimal number system. So 136 is the hexadecimal, but we know that 13 is equivalent in the hexadecimal number value is equal to D, right? So for that purpose you can represent D6, which is the hexadecimal number value. At the same time, fractional part is also converted in the same process. You have to carry out the multiplication, and with the help of a 16 you can take the integer part only. You can follow the top down approach. So let us see the step for fractional part also. Suppose if you want to convert a decimal number of 35, this is the decimal. You can, if you want to convert this one to the hexadecimal format, what shall we do? You have to follow the same procedure in the binary format. 0.35 into 16, then you will get approximately 5.60. Take the integer part. Integer part is nothing but 5 only. Separate this one. Again you have to carry out the remaining part. 0.60 into 16, you will get around 9.60. Take the remainder integer part 9. Then at the same time you have to carry out 0.60. Again you have to carry out 16. You will get 9.0. This process is repeated, right? So then you can stop this one. Otherwise, okay, the same process will be repeated. So in this case, if you want to get the finalized equivalent number, you have to follow from the top to bottom approach. So in this scenario, what shall we do? How can you represent this number? 0. fraction number 5999. This is the equivalent number of 16. So total value is 0.5999. So this is a way we are converting from any number system. Suppose if you want to converting the same decimal number system to octal number system, let it be say decimal to octal number system. So for this purpose, let us take any number that is used to converting from octal number system. I will consider 48. So I will consider 44 is a decimal number. You have to convert this decimal number into octal number system. So what is the value of 44? 44 is equal to 8. Because of our converted targeted decimal number, targeted number system is nothing but octal number system. Okay. So targeted number, so 8 5s are 40, right? So you will get reminder. Therefore answer is, you will follow in this direction, bottom to up direction. Therefore 54 is the equivalent number in case of the octal number system, right? So these are the different conversions from decimal number systems to another number systems, like we are converting from decimal to binary, decimal to octal, decimal to hexadecimal. Okay, so next conversion is nothing but any base to decimal number system conversion process, right? So that will be seen in the next class.